Hi everyone, and thanks for joining me as we solve equations that involve roots and rational exponents. Okay, so let's look together and solve equations using roots first. So the first thing that we want to do is go ahead and isolate the term that has the exponent. So in my equation here, I'm going to go ahead and subtract the 7 first. And then I'm going to go ahead and divide the 3 on both sides. And then I'm left with the term that has the exponent only. So when I get to this point, I'm going to go ahead and take the same root of both sides. So right now I have my x that is raised to the 5th power. So I want to go ahead and raise both sides to the 5th root. Now on your TI-84 calculators, you can go ahead and find the 5th root of 32. So what you're going to do is you're going to go ahead and go to the math button on the left, and you're going to go down to option number 5, and using this option will allow you to go ahead and find the 5th root or the 4th root or even the 8th root. And when I go ahead and take the 5th root of 32, I get an answer of 2. Okay, so here's another equation when we're going to solve using roots. So let's go ahead and isolate the term that has the exponent. So right now I have an expression that's raised to the exponent. So the very first thing I want to do is get rid of the -4 that's in the front. Now I'm going to go ahead and divide both sides by -4, and I'm not adding because this is -4 times that quantity. I'm going to get x minus 3, and it's still raised to that 4th power, and then I'm going to get 16. Now that I've isolated the term or that expression that has the exponent, I'm going to take the same root of both sides. So I'm going to take the 4th root of both sides. Now again, remember you can go ahead and click on math and then find option number 5 to get the 4th root of 16. Now, if you're taking the root and that root happens to be even, when you get your answer, don't forget to put that plus minus sign. So once I get to this point, I'm going to go ahead and add 3 to both sides, and I'm going to get 3 and then the plus or minus 2. Remember that plus minus sign is going to stay with the 2. It's not going to be added with the 3. So now I have two options. My first being I can go ahead and do 3 plus 2 first, which gets me an answer of 5. And then my other option is I can do 3 minus 2 and get an answer of 1. Okay, now we're going to go ahead and solve equations with rational exponents. So the same thing, we're going to just isolate now that expression that has the rational exponent. So I'm going to add 8 to both sides, divide both sides by 3. So the exponent is 4/3, so the reciprocal of that is 3/4. So both sides are going to get raised to the 3/4 power. Now, if my denominator of that reciprocal power is even, when I go ahead and write my answer, I'm going to always put a plus minus sign. So 81 to the 3/4 power is plus or minus 27. Now at this point, I want to check for extraneous solutions, and this being that an even power actually cannot equal a negative number. So I want to double check, and that being when I look at 81 to the 3/4, this is technically rewritten as the 4th root of 81 to the 3rd power. So I want to make sure that my answer is actually going to be okay. So what I'm going to do is I'm going to take the positive 27 as well as the negative 27, and I'm going to substitute those values in back into my original equation that I started off with. So when I do that, I want to double check. Okay, does my left side really equal the right side? In this case, when I plug this in, I'm good. They both equal 235, so my answer is going to be both positive 27 as well as negative 27. So here's another example. Let's go ahead and isolate that term that's got the rational exponent. So let's go ahead and subtract 36. And now that I have x to the 5/4, I'm going to raise both sides to that reciprocal power. So the reciprocal of 5/4 is 4/5 on both sides. I'm going to get x is equal to 16. Now that denominator of that reciprocal power was not even, so I'm not going to have to put the plus minus. I am going to check for extraneous solutions. So when I take that 16 and I plug it in for x, and I double check, does the left side of my equation equal the right side? I'm actually going to notice that it's not, so that answer of 16 is actually not going to be a solution, so I'm going to write as my final answer, no solution. Now in this example, we have an expression in parentheses that get raised to a rational exponent. So let's first go ahead and isolate it. Let's add 9 to both sides. Now I'm going to raise both sides of my equation to the reciprocal power, so to the 5/3 power on both sides. I'm going to go ahead and solve for x one more time, taking that 7. And I've got 236. So again, I'm going to check for extraneous solutions, take that 236 and plug it back into my original equation right here for x, and double checking, does my left side equal the right side? So now in this case, it works. So my 236 is a solution to my problem. Now here's my last example. We do have an expression in parentheses here that we're going to go ahead and isolate. So let's subtract that 10 from both sides. And again, raise both sides to that reciprocal power, so 5/4. Now, don't forget that the denominator of this reciprocal power is even. That's the 4. So when I write my answer for 16 to the 5/4 power, I'm going to put that plus minus sign with that 32. Let's add 12 to both sides. And now you're going to see that you have two options. You're going to have the 12 plus 32 as well as the 12 minus 32. You're going to get your answers 44 as well as negative 20. And again, we have to check for extraneous solutions. So let's go ahead and take that 44 and that negative 20, plug it back into my original equation and check, does my left side equal the right side? When you plug that into your calculator, you will notice that both of these answers are good. So I have my solution of 44 as well as negative 20. Okay, so here are some things for you to remember. Don't forget to check for even roots, because those could give you two answers. And as well, an even power cannot equal a negative number. That is when we were checking for extraneous solutions. Now I hope this video was helpful and you're able to solve equations using roots and rational exponents. Thanks for watching and have a great day.